Good morning, good afternoon, and good evening to all of you. We have a huge number of participants today coming from different parts of the world. So welcome to this third webinar. Just to come back on this trilogy, we started beginning of July with the first webinar dedicated to the persistence of microbial hazard in food safety. The highlights from EFSA scientific opinion with Brice Mainviel from Kersia and David Thomas from bioMérieux. Then we had in September a focus on monitoring hazards, importance of a good environmental monitoring program to seek and destroy with John Ola and Lina Otero. And today I'm very pleased to welcome you to this third webinar dedicated to root cause analysis, a new era thanks to Genomics. And I have the pleasure to be with Magali le Diodic, Market Manager, Food Safety and Dry Cleaning at Kersia. So welcome, Magali.
Thanks, Guillaume. Hi, everyone.
So you are all on mute mode. So to ask a question, please click on the question icon in the toolbar. The webinar is recorded, so we will send you the link after the event for your convenience. And please, if you can take time after the session, we will send you a satisfaction survey. So please take 2 minutes to answer the question. So as an introduction, we have a growing regulatory context regarding preventive food safety controls. With FDA, FSSC, SQF, and recently, in January 2024, the EFSA published a scientific opinion on the persistence of microbiological hazards in food and feed production and processing environments. So this, I would say, study highlighted part of the study controlling hazard with a seek and destroy approach that we already deep dive in the second webinar. And today we will focus on root cause analysis approach and mainly source tracking by identifying the source of the contamination. We will focus on Listeria monocytogenes because Listeria monocytogenes is still one of the most, I would say, important pathogen in Europe in food industry, and we see more and more, I would say, recall about Listeria monocytogenes all over Europe, and for us, it's important to focus and to help you to better address and to decrease in the future this high number of cases. So what is source tracking? So let's play a little game to start this webinar. So the objective as a credo is to search the lost spoiler or the lost pathogen with Listeria monocytogenes. So we have a process here. It's an example, it's a dairy company. So we have different parts in the process, different area, and the contamination risk also is not the same, of course, in the different parts. So we have yellow area, we have orange area, and we have high risk area where the contamination is very critical. So you are managing your control, you are following the positive or negative detection on your finished product, of course. So everything is pretty good, and a positive detection arrive. So you will, of course, try to understand by looking at the different environmental sample, raw material sample, and you will see that, of course, when we are looking for, you will find different positive detection. But the question is, which one is responsible of my finished product contamination? So this is why typing and source tracking is key. We will give colors to your investigation in order to help you to understand what happened in your facility and what is the root cause of this contamination. So let's take now a concrete example of a root cause analysis in the food industry. So once upon a time, Lucille, a production manager of a cheese factory, she runs the production, and its mission are, of course, first to avoid Listeria monocytogenes contaminations, to optimize the cleaning process, because we know that there is a huge pressure to be more, I would say, responsible, and to stick to the budget, because it's also something key for the efficiency of the company. So Lucille has only one fear, that a positive will be detected on the finished product. And unfortunately, this positive detection arrived at the week 1. So she don't want to take any risks, so she managed the batch destruction. She stopped the production, but she has many questions. Have I ever encountered this strain? Is it a true contamination or cross-contamination? Is it persistent? Is it a biofilm? Is it coming from a raw material? A lot of questions, but Lucille don't have time to answer. So basically, she prefers to perform a full cleaning, which is quite costly and time-consuming and water-consuming, but she is pretty confident with the efficiency of this huge cleaning. So everything is going pretty well during 2 weeks, and the third week, again, a positive detection. So same process, destruction of the batch, stop production, full cleaning, and unfortunately, she's not able to restart because week 4, positive detection again in the finished product. So she arrived in a crisis management, and she has to stop the production because positive detection are everywhere. So by chance, she validated a budget some years ago to have the possibility to automatize and digitalize the environmental monitoring plan thanks to a software named EnviroMap. And she looked at the picture to see where the positive detection are compared to the negative detection of Listeria monocytogenes. So what we see that we have different positive detection at the reception, in the production, at the maturation step, in the cleaning room, but it's still difficult for her to understand exactly where she has to look for to find the root cause. But Lucille must act, because after 3 weeks, the consequences are significant. Financial impact start to be important, water consumption during successive reinforced cleaning, and also time consuming at the team level. The situation is still not under control. So it's time for you to answer the first question. So you will find it in the chat. So you have to expand your window to see the poll. What should you do in this situation? I give you a few seconds to answer. So I will have a look at the results just after. Okay. So the question now for Lucille is, and if I had known from the start the origin of the contamination? So coming back to this, I would say, timeline of the crisis, if at the beginning, at the first positive detection, Lucille was able to perform a genotyper, a strain typing analysis on the Listeria monocytogenes, she was able maybe to understand directly the contamination, and it will allow her to make the best decision. And maybe after that, she will save the issue, and she will not encounter a new positive detection in the future. And to remind you, Genotyper, this kind of typing solution, give colors to your investigation in order to help you to understand quickly what happened in your factory. So if we zoom on what happened in this cheese production factory, we can see that we have one cluster of Listeria monocytogenes that we found in different samples because she performed Genotyper on different positive detections. So we have the finished product here, and we see that we have 3 other samples, environmental samples, which are linked to the same cluster, so to the same Listeria monocytogenes. But it's quite difficult to understand what happened with this table. So if we go back to EnviroMap, we can see that we don't have one Listeria monocytogenes issue, but we have 3 different Listeria monocytogenes issues. We have one that we found only one time at the reception, the red one. We have another one found in the reception area and production area, the green one. And we have one, the blue one, we found at the reception and in the maturation area. But the question is, what happened? Because the traditional, I would say, process, the traditional, I would say, flow in the factory is from reception to maturation. So it seems that something happened in this factory by this carrier, and the contamination, the carrier came from reception to maturation. But it's not something usual. So maybe someone, because it's easier to go through this way, moved directly to the reception to the maturation step, and thanks to that, he contaminated all the area. So what we learned from this expertise, that the root cause is linked to the cart wheels and an inappropriate flow. So it means that we will now be able to address, and Lucille will be able to address, the 3 different issue contamination in a proper way. So again, now, second question, do you think that we have enough information to mitigate the contamination? So I don't know, Magali, if you see the answer on your screen, because I don't have, with the presentation mode, I don't have access.
You can wait some seconds more.
Okay.
Third people think yes, we have enough information, and 67% no. We can continue.
Okay. So Lucille is more serene because she can finally analyze the root cause, because she understood what happened. So she understood the phenomena of strain circulation in the factory, and she can now propose more effective action plan. And she hopes that thanks to that, she will be able to reduce the prevalence of Listeria monocytogenes, to reduce, of course, the food waste by not, I would say, scrap different batches, and optimize and reduce water consumption thanks to the cleaning efficiency. But we can go beyond that. Indeed, we have one question we still need to answer. Is it a recent introduction of this Listeria monocytogenes, or is it a strain which is persistent since a long time in the factory? And also, the second next step should be the action plan for floors and water residues. How we can manage this action plan. So to answer the first question, is it, I would say, a recent or persistent strain? We can go beyond after the Genotyper analysis, we can perform what we call pathogen mapping. Pathogen mapping is using whole genome sequencing to determine the amount of DNA mutation between isolates. And this number of mutation determine exactly how related isolates are to confirm that they have the common source first, so we can confirm, but more important, we can have an idea. If we have a lot of mutation, it means that it's probably there since a long time. And if we have a few mutations between isolates, it means that it's probably a recent introduction. And we can also look at potential resistance gene against biocide, against metals, also some genes implicated in biofilm creation. So we can have much more information to, I would say, to deep dive in the investigation. So in this case, we perform Lucille ask pathogen mapping, whole genome sequencing, and she confirmed that we have a significant mutation between isolates. So it means that this strain is probably persistent in the environment since a long time. So Magali, what can we do to, I would say, mitigate this contamination?
So at this stage, Guillaume, in Kersia, we take over the file. So we know, thanks to the site and thanks to your study at bioMérieux, we know that there were 3 strains. The first one was not really important. It was important, but it's okay for us because it was mastered. It comes from the external flow, so it's okay right now. The second one wasn't impactant. It was just one sample, one positive result in reception. But there is still the third one, I think it's the green, which is already in production. So we decide, the blue, sorry, thanks. So we decide to focus on this one, the blue strain, and cross-check the results going on site. And more precisely, to have a look on the floor and the environment and the cleaning protocol. So you can go to the next slide. We went on the site to make a global audit. The aim of this audit was to have a look on the environment and the cleaning, to detect, to understand what happened, and to see if there is any drift for, at the end, making the best or the right proposal. So we go on site, and you can go on the next one, Guillaume.
It's okay, I think.
Yes, perfect. So we go on site, and we show that they were using a 5-step cleaning. The cleaning had 3 main issues. The first one was the quick preparation of surfaces before the step cleaning. And the second issue was the protocol used. They used a 5-step cleaning, which wasn't really appropriated to the factory. The third issue was water residues regarding the Listeria issue. There were a lot of water after the cleaning operation. So we can show it on two pictures. The first one on your left is a picture in the floor after the cleaning operation. So you can see there is a lot of water residues. And on your right, you see the floors few hours after the beginning of the production. So after cleaning, 3 hours, about 3 hours after the beginning of the work. So regarding the water residues, it's easier for the germs and for the dirt to grow up. So at this step, we can say, okay, the problem are the floors, and perhaps it's due to the sewers. but we want to be sure that it's really the case. So we ask what happened before this step, and we decided to go further. So we have a look of the global situation and in the global cleaning. So you can go on the next pictures. Yes, they were using the same protocol for the cleaning of conveyors. And in those conveyors, there were some rollers, some hollow rollers, which were cleaning by the same method, so a wet cleaning. And this protocol wasn't really appropriated to these elements. So we decided to make samples inside those rollers, and we put up to bioMérieux. And bioMérieux say, yes, it's the same strain that we found on the floors. So the root cause wasn't the floors, it was an effect of this contamination on the rollers. And more precisely, it was due to the hygiene conception mixed with a non-appropriated cleaning protocol. So we review the cleaning protocol, and we proposed a dry cleaning protocol. When we make this audit, we also saw a lot of other things, like this example, which wasn't as important as the previous point for Listeria issue, but which could be a big problem for other germs. Here you can see one thing which is really interesting for the grow-up of germs. In the previous webinar, John talked about the flow and air compressed. So here you can see that air compressed was used to easily remove the dirt before the cleaning operation. So Kersia proposed to contain the dirt, to contain the germs by using the good or the right protocol cleaning, and to use for example, vacuuming and another method. So here, before you spread the germ, and now you contain it. So we put in this site method, tools, with first, to sum up, an appropriated cleaning protocol with dry cleaning, and also with the securization of elements difficult to access with airborne disinfection without rinsing. We also help the staff with knowledge and training. And the next step to be continued is to make another audit to show the hygiene conception, the evolution of this point, and to make improvement in this site. So what can we learn about this study case? The first lesson is to never neglect the repercussion that environment can have on your products. The environment is really important to master. The second point is to make the link with your activity. A cleaning protocol can be good, but not the best, not the right protocol in your activity. And the third one, which for me it is the most important, is to have the most knowledge you can. If you know your NMI, it's easier to find them. It's easier to have the right solution at the right place with the right protocol.
Thank you, Magali. So to know our enemy, I would say very well, we have the microbial typing as we presented in this example. So what is microbial typing? So go back to, I would say, the taxonomy. When we are speaking about Listeria, we are speaking about the genus. When we are speaking about monocytogenes, we are speaking about the species. So basically, all the methods we are used to use in a routine basis give you the genus and the species. But the question after is how we can go deeper, how we can type our strains to group the isolates of the same species at the subspecies or strain level. So this is where microbial typing become more and more key to help you in this kind of investigation. So if we look at, I would say, this taxonomy and the different method we have at our disposition, we have, of course, identification, so to confirm Listeria monocytogenes. So many of you are maybe using 16S or MALDI-TOF to confirm just genus and species. And then you have before whole genome sequencing, which is at the top right and which is the most accurate methods. We have methods like PFG and MLST, and genotyper is at the same level, I would say, of accuracy, but the main value is the time to results, because instead of waiting an information with PFG and MLST during 2 or 3 weeks, we are able in 1 hour from the strain, from the isolate, to give you a clear information, a first level of information of the sequence type and the strain typing. So how does it work? So you are used to work with the GenUp for detection. So GenUp is a PCR platform we are using at bioMérieux. And GenUp Typer, you can use this kit on the same platform that the one you are using for detection. And this is a new kit, I would say, a combination of a PCR test and I would say a data model, a data algorithm, which will analyze the results from the PCR. So first, how does it work? We are taking a sample, we are performing the enrichment, we are performing the Listeria monocytogenes detection test. Very simple workflow, and we have a positive detection. So at this stage, what you are doing, you are isolating from the broth to confirm the positive detection on a plate. So it can be ALOA, and from ALOA, you will run the genotyper test. So you will start directly from an isolate colony on ALOA. You will perform the same protocol, lysis and PCR on GenUp, and then you will have directly a report directly linked to the communication between the GenUp and what we call Augmented DX platform, which is a secure cloud-based solution, which will give you all the results, all the information, all the historic data you can see on the screen of your previous genotyper testing on Listeria monocytogenes. So if I connect, I would say, to my dedicated platform, I can see all the cluster of Listeria monocytogenes I have in my factory I found in the past. If I look on the right, I can add customizable metadata. So you can put here I would say the name, the identification of your samples with the date, the product, the site, the sampling point, the source, etc. You can also run genotyper on your lab strain in order to see directly in a very, I would say, a short time to result if you are facing a cross-contamination. We know that a certain part of the positive we may have at the lab can be linked to cross-contamination. So it's also an opportunity for you to see it as soon as you can. And of course, if you ran in the past some whole genome sequencing, or if you have, I would say, historical data, FASTQ file, you can upload directly on the application all the data coming from whole genome sequencing in order to run in silico the genotyper profile to be able to reuse your historical data from whole genome sequencing to compare them to your recent genotyper analysis. And by clicking on the cluster name here, you will have access to all the samples which are part of this cluster with all the data, the sampling date, and you will have access also to a dashboard which will tell you very visual way the number of strains linked to this cluster, since how long this cluster is present in your factory, etc., etc. So Genotyper has a resolution comparable to MLST, and it will tell you if the isolates are related or not. So it will help you to take the right decision in live, in your own lab, or with an external lab, Mérieux Science, because it can be also managed externally with Mérieux Science. It's really easy to perform and fast. And you can combine that if you want to go deeper to whole genome sequencing to have highest resolution in order to know precisely how related are those isolates and to go deeper in the understanding of some, I would say, virulence, resistance to different biocide metals, and also if we can have a potential biofilm forming this time monocytogenes in your factory. So now with Genotyper, you know faster, then you know where it comes from, then you know what it is, then you know what to do, then you know. And this is the power of this tool. So Magali, how, if we have to summarize the methodology we can provide for source tracking?
Yes, thanks, Guillaume. So thanks to those tools, let's go back to the beginning. What can be the right methodology for a source tracking? So you are on your site. Yes, thanks, Guillaume. You can go to the next slide.
Sorry.
So our field team in Kersia is every day on your factory. The aim is first to ensure the standards are okay regarding your activity, your product, and also your requirement. But sometimes, not only because we are not on your side, sometimes there is a drift, an issue. So we had to put a methodological approach to ensure you quickly that you take the right decisions. The aim is to clearly define what happened, what is the problem, to analyze the situation in depth, and to put the right solution and ensuring everything would be okay, everything would be under control and updated. So the first step, yes, thanks. The first step, you had a contamination on your site. So the first step is to ask the more question you can. What are we facing? Are you just positive results on your environment, or is it recurrent? What happened to your product? Is it contaminated? Is it a deviation, an exceed limit, a random, etc.? The second question is to put your product. No, you can. Sorry, Guillaume.
Excuse me.
No problem. So the second question is to put your product at the heart of this analysis. What does it mean for the consumer? This quick analysis can help you to evaluate what is the urgency. Do you have time, or is it an urgency and I have to put the most means required? Just before going to the next step, keep in mind that when you've got a contamination, there is a lot of failure. Barriers are not efficient. So there is a lack. The microorganism is introduced in your factory, multiplicated, and persists. So the first step, say, okay, it's an urgency or not. I have time to reflect. You can go to the investigation. For that, there is a lot of tools who are existing. Just keep in mind that this investigation had to be sustainable. It's for a sustainable resolution. So you had to identify the root cause. So there is a lot of tools, the 5 Whys, the 5W and 1H, Ishikawa diagram, etc. And another thing which is important, never be complacent. Always stay vigilant for a sustainable resolution. So it's in your side. Now we can go to the next step, the third step, and it's to cross-check, to cross over the data. So that at this stage, that Kersia go on the experience for an analysis of the drift, the deviation for the treatment. And when we cross over our data, when we cross over our experiences with bioMérieux, with you in the factory and with us, it's always easier. We go faster, further, deeper, and it's easy to understand what happened. So this approach is really interesting. So now we get on the right track. We can go on site to make some samples, some study, and for a better understanding of what happened. So we can put some tools with audits, like detergent qualification, like biofilm diagnostic, like looping test for having a look in the surfaces and the circuits. We can make samplings or flow audits for environment and or air. And we also can have a look of method of production, of learning, etc. And after this audit, we can put the next step for a treatment, the good treatment, the appropriate treatment regarding what we found on the previous step. So when we go out of this issue, the next step is always be vigilant. And the most important to learn when you have an issue is to learn from this experience, to go further, to anticipate the next step. So we can put some implementation, some tools, and we had to use the data with crossover the data with bioMérieux, with you, etc.
And this is something we will probably, I would say, launch in 2025, a series of webinars dedicated to how we can use data for preventive food safety and quality risks, because we started to, I would say, collect and to develop some algorithm to support you in this field. And the first results are quite impressive. And just to give you an example, on a food industry site, we analyze all the data coming from all the results of the environmental monitoring plan and the finished product results. And with a smart adaptive sampling, we are able to anticipate by 30 days the detection of a problem. It means that during 30 days, you don't see enough signal and you are facing a contamination event after, and with, I would say, data analysis, we can detect 30 days earlier an issue which is starting to, I would say, increase. So it's really, really powerful. So that's why data is so crucial. So first we need the data. It's always the same question, Magali, but very interesting part. Thank you. So maybe to finish, this is the last slide. This is interesting also to share in this webinar. We were also very happy to share how we can have a synergistic, I would say, approach with Kersia, because we have at bioMérieux a huge expertise in advanced microbiological analytical tools, molecular, genomics, data science and expertise. And this, I would say, those new insights which will, help Kersia, because this is the next step in the, I would say, cleaning and disinfection solutions, food hygiene and food process expertise, auditing, training, holistic optimization, and together in this kind of, I would say, troubleshooting situation, we are able to deliver, I would say, better efficiency at the food industry level by improving social performance, environmental performance, financial performance, and of course, food safety and quality assurance. So thanks a lot for your participation. Thanks a lot, Magali, for I would say, conducting this webinar with me. We have some questions. The first question in the chat are linked to the advantage of genotyper compared to classical serotyping and whole genome sequencing. So maybe I answered. I don't know when this question arrived, but maybe I answered by the description of genotyper. The main value is time to result, because if we maybe Magali will answer after, but from now, when we perform typing, it's after. It's to understand what happened, but we cannot wait 2 or 3 weeks to take action. So basically, you put in place a mitigation, and then you perform typing to understand what happened in the past. But it's already too late because you put in place the action. Genotyper will allow you the possibility to act and to take action thanks to the information that it will give you. So it's a big game changer because you will be able to act with this knowledge of typing. So it means, in your example, Magali, to adapt the cleaning process with this kind of information.
Yes, exactly. We've got the keys for a quick understanding and for the best proposal, the right proposal.
Yeah. So someone told me recently, we cannot solve an issue that we cannot understand. So it's clearly by understanding what happened, you will be able to better address the contamination event. So I think we are on time. So thanks a lot for your participation. Thanks again, Magali, for your time and your this nice webinar.
It was a
Again,
pleasure.
thank you. Again, all the replay of the trilogy will be available. So you already received probably the one and the two, and the second if you participated to those. If you want to have to receive the replay, please send us a message directly, and we will share them with you. If you have any question, please feel free to ask. And if you have some suggestion on some topic you would like us to address in the next webinar trilogy beginning of 2025, please feel free to send us also your recommendation. So we wish you a good day, a good end of 2024, and we will come back beginning of 2025 with a new trilogy of webinar, more focus on data and how data expertise, data analysis, artificial intelligence in the food safety and quality area can support your, I would say, troubleshooting, but also your continuous improvement. Bye-bye. See you soon.
Bye.